Today I'm going over 6 main things to consider when deciding on a home charging setup for your Tesla. Cost of charging device, panel or breaker limitations, charging speed, daily driving distance, transportable and service, and aesthetics. So if you have recently purchased a Tesla Model 3 or Y, and if you have a house, you will most likely be charging in a garage, carport, or driveway. In previous videos, I have covered installing a 240 volt NEMA 1430 and 1450 outlets, and also showed charging on 120 volt outlets. This video will compare all of them and explain how these different ways of charging your car may be best for your situation. I'm based in the United States, so everything I will be talking about is for North America. Other parts of the world will have different solutions. I want to start off first with some terminology specific to EVs. Technically, these are not chargers, they're called an EVSE, or Electric Vehicle Supply Equipment, and are basically like a smart converter to provide power and communication to the car. I could do a whole video covering the different charging standards for AC and DC charging. I'll leave that for another time. Back to the EVSE. The Tesla charging equipment commonly used are the mobile connector, one of which is included with every new Tesla sold. They are also known as charging stations or charging docks. The primary function is as electrical safety equipment. You can also purchase or use non-Tesla EVSEs, which may be the case if you already have a non-Tesla EV. You just need to put the J1772 adapter, which comes with the car, on the ends of the plug so that it will work with the Tesla. It provides AC electricity to the car, which has an onboard charger that will convert it to DC for the car's battery pack. Once connected to the vehicle, the EVSE informs the car what power is available and at what level. From that point, the car takes over, initiates and takes full control of the power transfer, unless an electrical fault occurs, in which case the EVSE will stop the power transfer immediately. Another term that I will use in this video is Level 1 and Level 2. It's based on the voltage of the equipment. Level 1 is 120 volts, and Level 2 is 208 to 240 volts. No doubt about it, if you want the fastest charging speed, you need a 240 volt connection to your car's charging equipment. I'll show later in the video how much of a difference this makes between the two types. There are several different charging solutions offered by Tesla, which starts with the included mobile connector and goes all the way to the wall connector. Let me now start with the first factor, the cost of the charging device. I'll show you Tesla's website store, which has a whole page on charging. What's the difference between the mobile connector and a wall connector? Basically, a couple things. The mobile connector allows multiple charging outlet adapters to be used. For example, the mobile connector can charge at 120 volts or 240 volts, and at different amp levels with a variety of connectors. So a mobile connector is both a Level 1 and a Level 2 EVSE, depending on which adapter you use. Be aware it only comes with a NEMA 515 adapter, which is the common 15 amp outlet that you see everywhere. If you want a 240 volt adapter, you need to purchase it online. The mobile connector is included with the car, so it's the least expensive way to charge your car, whether you use 120 volts or 240 volts with the appropriate adapter, which are $35 to $45 each. You will need an electrician to install an outlet if one isn't available. If you want to keep the included mobile connector in your car, you can just purchase another mobile connector. They are around $275. The key word is mobile, which it can be unplugged and moved easily. Second, a corded mobile connector is $400. It provides faster charging at 240 volts than the included mobile connector. It has a fixed connector, so that's the only outlet you can use. So basically, it's a compromise between a mobile connector and a wall connector. Next, the wall connector is another option to charge at 240 volts. It is currently listed at $495 on Tesla's website. The wall connector is 240 volts only. It is mounted to a fixed location and can be connected in one of two ways. All of the current wall connectors sold by Tesla require a direct wired connection, meaning no outlet is used. Wires from the house are connected directly to the unit. Tesla has sold wall connectors that had a NEMA 1450 plug that could use the 240 volt outlet. However, they currently don't list it anymore online. In addition, Tesla used to sell wall connectors with 8-foot and 24-foot cables. Now only the longer version is sold. The wire cable on the wall connector is also much thicker than the mobile connector, as seen here in this video. The next topic is panel or breaker limitations. Basically, what fits in your electrical panel? Some homes have load centers, also known as electrical panels, which may be 100 amps. This can be a big limitation on the charging method that you can select. This may also happen if you have a 200 amp electrical panel with no more breaker spaces. I would consult an electrician to determine if there are ways of making a full panel work. For example, 2 single breakers may be replaced by what's called a tandem breaker, which basically fits 2 breakers in the space of 1. This could be done for some low amp circuits that have 15 or 20 amps. This may free up enough space to install a larger 240 volt breaker, which are double pole, which are twice as wide as single pole 120 volt breakers. This is my load center and it is 200 amps, and there happens to be a spare circuit breaker already installed. So if you have a spare, you're one step ahead. But as I said before, you don't want to be doing this yourself. Get an electrician to evaluate your load center and see if this is a possible solution. Another way to get more space is if you replace the original 100 amp load center with a 200 amp version. This can be a big deal and can be very expensive, potentially several $1,000s. This may also involve installing a larger gauge service line wire to your house in addition to replacing the load center itself. One positive of this improvement is that it will increase the value of your home and the amount of potential electrical circuits you can add. But what if you can't do this? For example, you are renting a house. You may be limited to charging on a 120 volt outlet, most likely on the exterior of the house or inside a garage. You want to make sure that the car's charging equipment is the only thing plugged into this circuit. Otherwise, you may have issues of overloading and you will have problems with charging. Before I leave the subject of breakers, I wanted to mention that if you have the ability to fit a 60 amp breaker into your installation, then the wall connector does offer an interesting advantage over other options. You can connect more than one of the newer wall connectors, basically daisy chaining them, so that they can share the same breaker and work together when charging multiple Teslas. The third topic is charging speeds. Before I begin, I want to do a quick explanation of how amps work when discussing outlets, breakers, and usable charging. For example, a 15 amp outlet, like the common NEMA 515 120 volt outlet, would connect to a 15 amp breaker. But the usable amount of amps is limited to 80% of the breaker and outlet size. For example, 80% of 15 is 12. So 12 amps is the max you can safely use on this outlet breaker combination. I'll start off with the slowest solution, also known as level 1 or 120 volt charging. A mobile connector at 120 volts, 12 amps, using a NEMA 515 outlet. I'll open up the storage bag and I have the mobile connector inside. I attach the outlet adapter to the main unit. I located a suitable outlet in the garage. It's a good idea to support the main unit so that the wire connected to the outlet is not strained. Once I have that installed, I plug it in. It's good practice to unwind the cord before charging. And now I can plug it in. The Tesla logo turns green when it is beginning to charge. I'll go inside the car and show you what it's doing. The charge screen is currently showing, and the max charge current is 12 amps as shown. This can be lowered if you wish. Go to the upper left part of the screen and you have the charging rate, miles added, amp level, and voltage. You can see that it's now charging at 4 miles per hour. By the way, the miles per hour are specific to the particular vehicle. A Model 3 may have a slightly different number than a Model Y or S or X. Pressing the miles to percent, you can now see that the charging is at 1 kilowatt. Next up is the mobile connector at 120 volts, 16 amps, using a NEMA 520 outlet. This is not as common, but this is the fastest level 1 or 120 volt solution. I'll swap the NEMA 515 for the NEMA 520 and show you the difference. For this example, I have a NEMA 520 outlet on the side of my house near the service entrance. Since it is far from my driveway, I will have to use an extension cord for this test. Please see the above video that explains how to use extension cords. They are normally not recommended, but if you provide the right kind, it will work fine. I attached the cable to the outlet and stretched it out towards the driveway. Then I attached the mobile connector with the NEMA 520 plug into the end of the cord. Now I will extend it to the car and plug it in. Now let's go inside and see what we get. I have to increase the current from 12 to 16 amps as it shows the max right here. With 12 amps, I got 4 miles per hour, but now with 16 amps, I now get 6 miles per hour, or about 50% more, which equates to 1/3 shorter charging times. Changing from miles to percent shows that I'm now getting 2 kilowatts. If you are limited to 120 volts, this is significantly faster than 12 amps. As I mentioned previously, this outlet requires a 20 amp breaker, and as such, the max you can use is 16 amps. Next up is attaching a NEMA 1430 adapter to the mobile connector, and then plugging it into a NEMA 1430 outlet, which is 240 volts, connected to a 30 amp breaker. If your electrical panel is limited, this choice offers an outlet connected to a 30 amp breaker, so the max you can use in this combination is 24 amps. Plugging it into the car, let's go inside and see. As expected, the charge screen shows 24 amps. And looking in the upper left of the screen, we have to wait a little bit as the amps are ramping up to 24. And when it hits that, we see it is running at 22 miles per hour. Notice this rate is significantly higher than the 6 miles per hour when charging 120 volts at 16 amps. Changing from miles to percent shows that we are getting 6 kilowatts. Remember that the car is rounding up these numbers. The actual kilowatts is 5.76. Next up is the fastest charging that can be accomplished by a Gen 2 mobile connector. For those panels that have enough space, a NEMA 1450 is a good solution. The max amount of this outlet you can use is 40 amps, since that is 80% of 50 amps. However, if you have a Gen 2 mobile connector that comes with 2018 and newer Teslas, it is limited to 32 amps, no matter how high the amps are offered by the outlet breaker combo. Here is one in the front of my garage. The outlet is connected to a 50 amp breaker in the garage subpanel. I'll plug in the mobile connector and attach it to the wall bracket, taking the cable and stretching it out, then connect it to the car and charge. Inside, we see that the charge current is 32 amps. We are now charging at 30 miles per hour. Changing miles to percent, we are now charging at 8 kilowatts, which, by the way, is rounded up from 7.7 kilowatts. If you want to charge faster, you could use a Gen 1 mobile connector like this one that I have in the garage. Another option is the corded mobile connector, which I showed earlier on Tesla's online store. That is a compromise between a Gen 2 mobile connector and a wall connector. It will allow up to 40 amps, just like the Gen 1 mobile connector, using the NEMA 1450 outlet, but it does have a non-detachable plug. However, these are $400 and usually out of stock. But this is a good option to keep in mind if you want to get a NEMA 1450 and don't want to buy a used Gen 2 mobile connector. It can use a max of 40 amps that the NEMA 1450 outlet can provide. I have it plugged in, and let's see what we have in the car. I will increase the charge current to the max of 40 amps by pressing the plus button multiple times. The charge level is ramping up and it will max out at 40 amps. Looking at the left side of the screen, you will see 10 kilowatts rounded up from 9.6. Press the percent to go to miles and you will now see that it is charging at 35 miles per hour. One thing I want to mention is that the Gen 1 mobile connector is no longer for sale. If you want one, it needs to be purchased used on eBay. There have been issues of overheating reported on the Gen 1 version. Mine has worked fine for 4 years. This is one of the reasons why the Gen 2 mobile connector was designed with a reduced amp level. You can also purchase a third-party EVSE that provides 40 amps of charging and uses a J1772 adapter on it if you prefer. I'm in the process of reviewing one and will have a video shortly on how this will work. The other version of level 2 charging is hardwired. The Tesla wall connector is a good example. You can use a 60 amp breaker with the wall connector. This will allow a max of 48 amps to a Model 3 or Model Y. I want to mention that the wall connector does have a reset button on the outside of the main unit in case there's a problem and you need to restart it. Mobile connectors have to be unplugged to be reset. Thanks to Gary Yorkdale for providing me the ability to video his wall connector setup at his home. By the way, older Tesla Model S and X models from 2013 to 2016 could charge faster than 48 amps. Wall connectors supported dual chargers on some models that went as high as 19.2 kilowatts or 80 amps. However, current Model S and X can charge up to 11.5 kilowatts or 48 amps, the same as Model 3 and Y. I'll attach it to the car and show you. Looking at the screen, we can see that the charge rate is increasing to a max of 48 amps. And now we hit 48 amps and it is 11.52 kilowatts, which is rounded to 12. By pressing the percent button to get to miles, we can see that it is providing 45 miles per hour of charging. I want to mention that the standard range Model 3 has a max of 32 amps for charging, so a wall connector doesn't provide any benefit for faster charging. Part 4 is daily driving distance. If you find yourself driving 200 miles a day or more, for example, using a full battery pack, then I would definitely recommend spending the money to add a NEMA 1450 outlet for a mobile connector or a hardwired wall connector. If you use around half the battery pack or less per day, I would say a wall connector is not necessary and a NEMA 1450 or 1430 is plenty. If you drive 25 to 50 miles a day, it's possible to get by with a mobile connector on a NEMA 520 outlet. You can charge up overnight with no issues. And finally, if you drive less than 25 miles a day, it's possible to get by with a mobile connector on a NEMA 515 outlet. You can charge up overnight with no issue. These are just rough estimates, and if, for example, you want the ability to charge quickly, say for a long trip on a short notice, the first two options are probably going to be the best choice for you. Another thing to keep in mind is that if you have other charging available, if your job has a location where charging is provided, that may make a big difference in how much charging you need to get at home. Also, some people have a lot of local public charging infrastructure and the time to use it, so keep these things in mind. First, any of the mobile connectors can be transportable and easy to move. For example, if you have a vacation home, you could move the connector when you need it. Second, if you have a problem with your charging equipment, it's a lot easier to replace a mobile connector than a hardwired wall connector. In fact, if you have 2 mobile connectors, that is good insurance. Buy an extra one for the house and keep the original in the car if that's important to you. And finally, we come to aesthetics. Another reason people get a wall connector is that it just looks cool, especially if you get the replacement glass faceplate cover. For some, just the clean look of the hardwired installation is worth the cost. So to summarize, you have level 1 or 120 volt charging with 2 flavors: 12 amps, which provides 4 miles per hour, or 16 amps charging with 6. Next is level 2 or 240 volt charging with 2 methods: by outlet or hardwired. For outlets, there are a number of options. I recommend either the 1430, providing 24 amps and 22 miles per hour, or the NEMA 1450, providing 32 or 40 amps, around 30 or 35 miles per hour, respectively. Hardwiring will allow you to have the fastest charging using a wall connector and a max of 48 amps charging for newer Tesla vehicles, excluding the standard Model 3. This gets you 45 miles per hour. As you can see, there are a wide range of charging speeds from 4 up to 45 miles per hour. If you want, one thing you could do is just start off with the free solution of using the mobile connector on a 120 volt outlet and see how it works. If it doesn't work, you can look at the other options I have shown. If you have an outlet in your garage or home and you're not sure what type it is, I have included a link in the video description to help. There are quite a few different NEMA outlets out there. If you can determine the identity and if there is an adapter, that makes it easy. Most 240 volt outlets are usually the only outlet on the circuit, which is a good thing. For 120 volt outlets, there is a possibility of other outlets on the circuit. So if you use an outlet for charging, you want to make sure it's the only thing connected to the circuit. Otherwise, you could possibly get overcurrent or short circuit and will trip a breaker or worse. If you lower the amp setting, you may be able to use it, but this will degrade the speed with which you can charge. Of course, there are a lot of details with regard to electrical circuits that could affect your charging setup, and that goes beyond the scope of this video. For example, if your home's load center is overloaded or not. If you are uncertain, please contact an electrician so that they can determine if your charging plan is correct. It's better to be safe than sorry. I'm also not specifying wiring gauge size in this video either. That can be affected by the distance from the electrical panel as well as the amp rating of the breakers and outlets. Generally, you use 4 to 6 gauge wire for 50 to 60 amp 240 volt and 12 gauge for 15 amp 120 volt and 10 gauge for 20 amp 120 volts. I hope this helps you make a decision into what kind of charging setup you want to have at your home. See the link above for my charging playlist, which covers other charging subjects and some of the things in this video in more detail. If you have any questions or comments, please leave them down below. Thanks for watching, and I will see you in the next video.